Okay, so we've made this flow chart. We did two sides because Mrs. Slauson isn't quite sure which is the better side. And the idea of this flow chart for solving is to help you get through the mile marker. So start using the flow chart during the practice. Unfortunately, you will not be able to use it on the mile marker, okay? So again, when we approach these problems, you know, we've solved so many different problems over the course of the semester that what is the best way? So if you look at the first way we did this, you know, the problems all on the front side are the type where, you know, we have one type of X or more than one type of X. So I'm going to take a look at the problems that have more than one type of X and just kind of remind you of what you need to do. So if there's more than one type of X, so going to the first page on this problem, you know, more than one type of X is problem 1, it's problem 2, it's problem 4, I'm going to scroll down, and it's problem 5 and problem 6. So in those problems, the idea is I need to get them into standard form, so highest power to lowest power. That means they also need to equal 0, and that the number that starts it off should be positive. That's called the leading coefficient. So number 1's great. Number 2, I would want to rearrange by moving the negative 7x over to the other side. So when I'm ready to solve it, I'd be solving 2x squared plus 7x plus 4. Okay. Number 4, same thing. It's not in standard form, so I would need to move the 50 over. So it'd be x to the 4th, the highest power, minus 23x squared minus 50 equals 0. When I look at problem 5, that's in standard form, and so is 6. So the idea is with more than one type of x, I'm going to try to factor. And if I can't factor, then if it's a quadratic, then I'll do the quadratic formula. And again, quadratics, just a little note up here, are where it's an x squared as the highest power. So higher ordered polynomial like x to the 3rd is the highest power or x to the 4th is the highest power, then again, you would still try to factor. But if you can't factor, then there's the other song of the rational root theorem that went, oh my God, Becky, and I'm not going to sing that for you. So I'm going to show you that problem, the one on the front side, that I would try to factor it, but as it turns out, I won't be able to factor it, okay? And that is problem number 6. So with 4 terms on my factor flowchart, we've got all these different pieces of paper, I would do the grouping method. I would start a GCF, but I don't see one, and I would group them. Sorry, I know you can see that word shift there. And I would try to, in the first set, take out an x squared. That doesn't happen. Or I can. But then when I go for my matching set, this won't be able to work. I can't take something out, multiply it back in, and get both negative 8x and negative 12. So factoring doesn't work. So then you're sad and you sing yourself a song. So sometimes that song is the quadratic formula, which you should be looking for in problem 1 or 2 because those are quadratic. So if you can't factor, then you do the quadratic formula. But if you can factor, if you can't factor here, then you do the rational root theorem. And the idea is you take the number at the end, negative 12, and you take the number in the beginning, 1, and you find their factors, and I'm not going to worry about the negative right now. And the rational roots theorem says if I take the factors of the constant at the end and I put them over, so they're the numerators of a fraction, and the denominator, you use its factors as the denominator, then I would get this list of 1, 2, 3, 4, 6, and 12. And again, there'd be a positive and a negative version to all of these because not only does 3 times 4 get you to 12, but so do negative 3 and negative 4. So again, what I did is I took the factors of 12, I took the factors of 1, the number in the front, they're listed here, and then I make fractions, and the factors of 12 will be the numerator and the factors of 1 will be the denominator. But when 1 is my denominator, I just have the same numbers, okay? So then what you're supposed to do is to start testing these numbers. And we do this L, the synthetic division. And I might test 1 first, I might test -1 first, 2 first, -2, 3, -3. And it's going to work when I get 0 at the end. And so let's say we start with 1. And I would take the numbers back in my original problem. And I would take their coefficients, so 1, 1, -8, and -12. And those would go in here, 1, 1, -8, and -12. And if it works, I get 0 at the end. And I always bring the first number down, and then I start multiplying. So 1 times 1 is 1. Add up this column, I get 2. 1 times 2 is 2. Add up this column, and I get -6. 1 times -6 is -6, and I'm not going to get 0. So 1 was not the right choice. So I will go ahead and share with you what is the right choice. It will be -2. So again, I bring the first number down, and -2 times 1 is -2. I add these up for -1. -2 for -1 times -1 is 2. I add these up, and I get -6. And then -2 times -6 is 12. And sure enough, I do get 0. And then the idea is this is the remainder. And since you get a remainder of 0, when you get no remainder, that means you have factors. So I go to the stuff on the left, and this is the constant. I put an x with this. I put an x squared with this. And now I'm going to take that 1x squared. I won't put the 1 plus -1x. I guess I'll put that plus -6. And I would factor it. And then this is just easy factoring, not tough to do. So easy factoring, if you want to make your x, I'm going to put my x up here. I need the factors of -6. That'll get me to -1. And those are 3 and 2, with the 3 being negative. And easy factoring says I can go to x minus 3, x plus 2. And then what makes these 0? One answer is 3, and the other answer is -2. And all the answers, remember this little 3 up here means, I should have 3 answers. So all the answers are 3, -2, and then the one that we put over here was another -2. Because again, joining these factors, as far as neighbors that meet neighbors, to get back to what I started with, this highlighted part, this -2 would make another set of parentheses. And if I multiply these 3 here, take the time and have neighbors meet neighbors, I will get back to what we started with. So that's kind of the tougher problem. I think it would be on page number 6, or on the front page, problem number 6. Okay? So the others, you should try factoring, the ones that we've circled. And then like number 3 just has one type of x. So when we said that there was one type of x, you're just going to, work to get that x by itself. So that means I need to move this -2, this 4, this 2, this -3. I need to get all that stuff gone. So you make your little checklist. And I just start moving stuff. So the addition, subtraction, there's a +4, but that's in parentheses. So I'll get that when I get to this parentheses step here. So I'll move the 3. So, first I'm going to start by adding 3. On the left side, that gives me -18. On the right side, I still have all of this. So now I'm going to move my multiplication division. That's that -2. So I'm going to divide by -2. Those cancel out. Divide by -2 here. And now I have 9. And on the right side, I still have x plus 4 squared. And now to get rid of the exponent, to undo an exponent, I'm going to square root both sides. So I'm going to square root this side and square root this whole side. Square rooting that 9 gives me not only 3, but it also gives me -3. And then square rooting the other side takes out that squared, so I'm just left with x plus 4. So now I actually have 2 problems to solve. One of them is x plus 4 with 3, and then the other problem is this x plus 4 with -3. And to get x by itself, I'm just going to subtract 4 on both of them. On the top, I'll get -1, but when I subtract 4 on the bottom one, I'll get -7. And again, this 2 means I'm going to have 2 answers. So one of them's -1 and one of them's -7. All right, so just moving to the back. Again, just kind of looking at some of these, number 7, just one type of x, number 8, just one type of x. And then you get into these others. We'll kind of talk about those in just a little bit, but those are the most recent chapter. So I'm going to get you a little bit started on 7 and 8 and then let you guys finish it. So on number 7, one type of x, I want to make this checklist going backwards. And the first addition subtraction I'm going to move is the minus 21, not the minus 3, because that's in that square root, so I can't get to that yet. So I'm going to add 21 first. So here's my left side. And over here's my right side. And now I'm going to move the 6 because that's multiplying to that square root, so I'm going to divide by 6. Gone here, divide by 6. Whoops, I forgot my x here. And that gives me 7 over here. And now it's not an exponent. I mean, a square root is like a 1/2 power, so it's in the same thing. But to get rid of an exponent, what I'm going to do is then, since it's a square root, I'm going to square this side, and I'm going to square root this side. So on the left side, I now have 4x minus 3, and on this side, I have 49, and now I'm going to let you finish from there. So moving on to number 8, because you can pause and then pick up. Again, one type of x. I'm just going to make my little checklist. And I'm going to work to get x by itself. So my addition subtraction that I'm going to move is the plus 2 because it's not in the parentheses. So I'm going to minus 2. So over here, I have all of this. Over here I have negative 27. So now I'm going to move my multiplication division. That's the negative 3. It's multiplying to the parentheses, so I'm going to divide by negative 3. And that's going to give me 9. So how do we get rid of 2/3? Well, that means I can't have an exponent. So an exponent that doesn't need to be there is an exponent of 1. And again, I've talked about this a little bit more recently, that you guys learned in elementary school that reciprocals always, when you multiply them, give you 1 as their answer. So to get rid of 2/3, I'm going to have to use an exponent of 3/2. So I'm going to take this side to the 3/2. It's an exponent. It's not, I'm multiplying the exponents, and that would make it 6 over 6, and so then I would just have 2x plus 1 over here. But on the other side, I'll take 9 to the 3/2 power, not 9 times 3/2. And if you just remember, 9 to the 3/2 power is the same as you square rooting 9, and then taking that and cubing it, sorry. So when you take the square root of 9, you get, you get 3, but you also get negative 3. So that's that part, because we're solving. So we don't know, when you solve, you always go for both answers. And then you cube it, and when we do that, we get 27, and we get negative 27. So now I'm going to have 2 problems, and I'm going to let you pick it up from here. So I know I'm running out of room. I'm going to move up to the top right. So one problem that you're going to solve is 2x plus 1 with 27 and 2x plus 1 with negative 27. And you're going to get very different answers. So don't think, that one answer is 10 and the other one's negative 10. That doesn't happen here. All right, the other side, when I look at these, it just kind of depends on what side of the cheat sheet you're going to look at.